According to him, what he states, the matter can be neither be created nor be destroyed. If you take a compound from the different sources, the compound must have a equal number of elements in a fixed ratio. Whatever the reactant and the product you use, that must be a gases, and those volume must be equal to the product. The mass of this product must be equal to the mass of the reacting substances. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Some Basic Concepts of Chemistry. Under that, we have studied about the significant figures. Along with this, we also discussed with the precision and the accuracy. And we have learned that to find out the significant figures, we have to follow the certain rules. Because in order to identify the significant figures, we need to follow the rules. Then only we can easily identify the significant figures, right? In addition to this, we also discussed with the dimensional analysis. So what is meant by dimensional analysis? The process of converting the one unit into another unit, right? And also I have explained you all with the one problem with the how to convert the inches into centimeter. Today, we'll move on to the next topic of this chapter is law of chemical combination. Under that, we are going to discuss with the law of conservation of mass, law of definite proportion, law of multiple proportion, and Guy-Lussac law of gaseous volume and Avogadro law. So let's see what is this law of combination first. So according to the law of combination, if you take any two reactant or any two elements, so these two elements must be combined and give rise to the product. If you consider any two element, it must be combined and give rise to the product. This is the law of combination. What does the law of combination states? According to the law of combination, it states that two elements are combined to form a compound. Two elements are combined to form a compound, and this was a law, and it was stated that two elements must be combined and give rise to the product. That must be a compound. Okay. And under this, we have to study the 5 different laws. The first one is law of conservation of mass, and law of definite proportion, law of multiple proportion, and Guy-Lussac law of gaseous volume, and the Avogadro law. So under the law of chemical combination, we have to study all this 5 law. So first I'll directly go to the law of conservation of the mass. So this law was first given by Anthony Lavoisier in 1789. In 1789, Anthony Lavoisier, he was a scientist, he put forward this law. So according to this law, it states that the matter can be neither be created nor be destroyed. According to him, what he states, the matter can be neither be created nor be destroyed. In a simple form, I have written myself that according to this law, which states that the mass of the substance produced by a chemical reaction is always equal to the mass of the reacting substances, which means to say that the mass of this product must be equal to the mass of the reacting substances. So this was a law was given by Anthony Lavoisier, and this law, which is known as law of conservation of the mass. So what does the law of conservation of mass states? According to this law, the mass of the reactants must be equal to the mass of the product. For example, if I take the hydrogen, react with the oxygen, forms a water molecule, right? Here you can see that atomic mass of hydrogen is 1, right? The atomic mass of hydrogen is 1, but here there are 2 hydrogen atom will be there, 2 into 2, so it is 4 gram, right? So this is a molecular mass of the hydrogen. Coming into the oxygen, we know that atomic mass of the oxygen is how much? 16. But here there are 2 oxygen atoms are combined and forms an oxygen molecule. So 16 into 2 is 32 gram, right? So if you add these two, it will become 36 gram. So this shows that the mass of the reactant must be equal to the mass of the product. So it was a very simple law which has been stated by the Anthony Lavoisier, and this law which is known as law of conservation of the mass. We'll move on to the next law, that is law of definite proportion, or this law which is also known as law of constant proportion. Okay, let's see what does this law states. This law was given by another scientist known as Joseph Proust. So he is a scientist. He is the first time he stated this law. So which is the law? Law of definite proportion. So according to him, he states that whatever the source of the compound always has the same number of element in a fixed whole number ratio. According to him, if you take a compound from the different sources, the compound must have a equal number of elements in a fixed ratio. The best example is water. If you take the water, we know that water will be available in the different sources, right? From the rain, I can get the water. From the pond, I can get the water. From the river also, I can get the water. But we all know that if you get the water from the different sources also, the molecular formula of the water must be H2O. We used to write it in the form of H2O. H2O means what? There are 2 hydrogen atoms must be there combining with the 1 oxygen atom. So it having a fixed ratio of 2:1. So this fixed ratio will never get changed even if you bring the compound from the different sources. So this was a clear idea was given by Joseph Proust, and he put forward the law which is known as law of definite proportion. The name itself shows that if you bring the compounds from the different sources, the compound must have elements that should be present in a fixed composition. Okay, it may be 1 or 2 elements or the combinations of 2 or more elements, but it must have a fixed composition. So this law was stated by the Joseph Proust. Example is water. Water will be obtained from the different sources, but it has a same number of elements in a fixed composition or in the fixed ratio. I hope you all understood with this definition. We'll move on to the next law. That is law of multiple proportion. So this was very important law. Most of your examinations, they are going to ask this law. And for your competitive exams also, it's very important. For most of your competitive exams, they are going to ask the question from this law. Okay, let's see what is this law states. So this law was given by Dalton in 1803. So this law was given by Dalton in the year 1803. According to this law, when two elements are combined to form 2 or more different compound, then mass of the one element should be constant, where the other mass of the element should be present in a simple whole number ratio. He states that if you consider any two elements, if it is combined and forms a product, any one of the element should have a same constant mass, but the rest of the other element should have a simple whole number ratio. Simple whole number ratio. Let's see with the reaction. You can take the example of the water itself. We know that the water will be usually formed by the combinations of hydrogen plus oxygen, right? Hydrogen and oxygen, they combine together and forms the water, right? So here you can see that two different elements are combining and forms the water. I'll take the another example, that is hydrogen combined with oxygen forming hydrogen peroxide. Hydrogen peroxide. This is another reaction where same hydrogen and same oxygen will be used and forms a different product, that is hydrogen peroxide. If you observe these two reactions, you can clearly say that hydrogen and hydrogen, these elements are same. Hydrogen element is same, right? Hydrogen elements are same and they have a fixed mass, right? They have a fixed mass. But compared to this oxygen, you can see that the mass of the oxygen will be different. Mass of the oxygen will be different and they are present in a simple whole number ratio. Here, the oxygen mass will be 16 gram and another oxygen gram will be 32 gram. Right? If you divide, they are present in a 1:2 ratio. This is for the oxygen atom. If you consider the hydrogen, the hydrogen, they are present in a 2 grams. Right? So, in both the reaction, hydrogen, they are present in a fixed mass, whereas the oxygen, they are present in a simple whole number ratio. So, this was the idea was given by the Dalton, and this law, which is known as law of multiple proportion. Law of multiple proportion. Remember, according to this law, if you use any two elements, okay, these two elements, when they are combining, they forms a product. They forms a product and these products are different. So, in the first reaction, we have observed that it forms a water. In the second reaction, you have seen that it forms a hydrogen peroxide. This shows that even though we are using the same element, the product will be different. But during this reaction, we have observed that one of the element, they have a fixed mass, whereas the rest of the other element, they have a simple whole number ratio. Their mass will be different. So, this was stated by the Dalton. I can give you another example of the carbon. Okay. We know that carbon will be combined with the oxygen and forms carbon monoxide. Carbon monoxide. Okay. Similarly, you can take the another example of carbon and oxygen combined to form a carbon dioxide. Combined to form a carbon dioxide. Okay. So, in these two reactions, we know that we are using the same elements, but the product will be different. In the first reaction, the product is carbon monoxide, whereas in the second reaction, the product is carbon dioxide, right? But you can see that the carbon will always present in the fixed masses, but the oxygen masses will be different. The mass of the oxygen will be present in the simple whole number ratio, as we have looking out at the water and also with the hydrogen peroxide. So, this was the law of multiple proportion. We'll move on to the next law, that is Guy-Lussac law of gaseous volume. Let's see what does the law states. According to this law, was given by the Guy Lussac in the year 1808. This law was given by the Guy Lussac, was a scientist, and the name itself will be given to the law. Okay, and in the year 1808, this was a scientist, he put forward this law. Let's see what does the law states. According to this law, when the gases are combined or produced in a chemical reaction, they do so in a simple whole number ratio by the volume, provided that all the gases are at the same temperature and the pressure. So according to this law, this states that the gases which has been produced, the gases are combined and they are produced in a chemical reaction. They are present in a simple whole number ratio at a all constant temperature and also at the pressure, at the same temperature and at the pressure when the gases are combined and they give rise to the product. Let's see the reaction. Here you can clearly come to know that what is the Guy-Lussac law states. Okay, so remember, so this law will be applicable only to the gaseous molecule. Okay, this law will be applicable only to the gaseous reaction. Do you all know that what is a gaseous reaction? When the reactant and the product, they are present in the gaseous state, then only we can say it is a gaseous reaction. Okay, the entire law what we have seen now, that is the Guy-Lussac law. So it is applicable only to the gases. Okay, so here you can see that hydrogen, it is one of the element combined with the chlorine. Both two reactants are in the gaseous state and they produces the HCl. They produces a HCl. It is also gas. So that what he says is, according to him, the gases are combined and produces a chemical reaction. They are present in a simple whole number ratio. You can see here 1 volume of the hydrogen combined with the 1 volume of the chlorine, so that the hydrochloric acid which is produced as a product, you know, that must be having a simple whole number ratio as that of the reactant. So here 1 mole of the hydrogen and the chlorine are combined, so that 2 volume of hydrochloric acid will be formed. You can take the another example of nitrogen and hydrogen. This nitrogen, they are present in a 1 volume, combined with the 3 volumes of the hydrogen forms the ammonia. Even though it is a gas, so it present in a 2 volume. So when the gases are combined, you know, they produces a product. This product volume should be same as that of the reactant. And remember, this law will be observed only in the gases. Okay, so hence it is known as a gaseous reaction, because the reactant and the product both are in the gaseous states. Remember, if you write this reaction, you must know that whatever the reactant and the product you use, that must be a gases, and those volume must be equal to the product. Okay, you can take the simple example of the hydrogen and ammonia. So if the hydrogen combines with the nitrogen, you know, it will form a ammonia. So 1 volume of the nitrogen, it is combining with the 3 volumes of the hydrogen, forming a 4 volumes of the ammonia. This is how you can clearly understand the Guy-Lussac law, which is stated by the Guy-Lussac in the year 1808. I hope you are understood with this law. We'll move on to the next law, that is Avogadro law. So this was a law was given by the Avogadro in the year 1811. In the year 1811. According to him, he stated that the equal volume of the gases at the same temperature and the pressure should be equal to the equal number of molecule. So if you consider any if you consider any compartment, so for that, if you imagine you are filling the 1 volume of hydrogen, on another hand you are taking the another compartment, so that you are going to fill the 10 ml of oxygen. So after combining these two compartments, that must contain the equal number of molecules as we have introduced on the earlier stage. You can clearly understand from this figure. So here I have taken out the 1 volume of hydrogen and 1 volume of hydrogen and 1 volume of oxygen just to form a water, because we all know that hydrogen combines with the oxygen forms the H2O, right? Hydrogen combines with the water forms the H2O. For that, I know that I need 2 volumes of hydrogen that have a fixed number of atoms, whereas the oxygen, in that oxygen molecule, it has a fixed number of oxygen atom. If these two elements are combined, that forms a product that is called as water. In that water, remember, it must contain a fixed number of atoms, though it is present in the reactant. So this was a law was given by the Avogadro. According to him, remember, the equal volume of the gases at the same temperature and pressure should contain the equal number of molecules. So if you maintain this, after this reaction, if you maintain at a constant temperature and pressure, so it must contain the equal number of molecules. Then only we can say it is a Avogadro law. Remember, according to this law, he took the 3 different compartments. In the first compartment, he shown with the 1 volume of hydrogen, which consists of hydrogen atom. In the second compartment, he took the hydrogen, that is a 1 volume of hydrogen, which consists of hydrogen atom. In the third compartment, he took the oxygen, which consists of oxygen atom. Okay, so if these 3 are combined, they forms a water molecule, as we all know from the reaction, right? This compartment should contain the same number of molecule as it formed from the reactant. So this was a law was given by the Avogadro. So this is all about the law of chemical combination. Law of combinations or the law of chemical combination, which is governed by the 5 different laws. The first one is the law of conservation of mass, law of definite proportion, law of multiple proportion, then the Guy-Lussac law of gaseous volume, and also with the Avogadro law. I hope you all understood with this laws which is there in this chapter. In our next session, we are going to discuss whether what is Dalton theory and what is the atomic mass and how to find out the molecular mass also we will discuss in the next session. Till that, I like to say that after watching this video, please write down the definitions, because I have written the definition in my own words, just make you to understand. And also for each law, after knowing the definition, you must understand the reaction also. What is there behind that definition, you must know. So once you understand that law, what is exactly which is saying by the different scientists, you will come to know the all reactions. Okay, till that, take care and we will meet you in the next session. Thank you.